So sets in Python. Set is an unordered collection of items. So what is the meaning of this? Right. So let's say if I have the items 1, 2, 3, right? So this collection is similar to 2, 1, 3 or 3, 1, 2, right? They all are same, right? That means order does not matter. That's why it is called as unordered collection of items, right? 1 2 3 is same as 2 1 3, which is same as 3 1 2 or any order, right? But the items are same, right? Here I have 1 2 3, here also I have 1 2 3, though in different order. So set is an unordered collection of items, right? So every element is unique, right? So that means in set we do not allow duplicates. So the idea is if I have 1 2 3 and 1, if this is these are the items which I want to put in the set, but I have one repeated, one is appearing 2 times here, right? So this is equivalent to 1 2 3. These duplicates are not allowed. Though you are writing an item twice or more than once, that will be considered, or that will be stored in memory only once, right? So duplicates are not allowed. So the set itself is mutable. That means you can change the contents of the set, you can remove the item, you can add the item to a set. Now, one of the major use of set data structure is we can perform all the operations like union, intersection, set difference, etc., right? Which otherwise we are not able to perform on other data structure which are quite similar to sets like lists and tuples, right? So this is a unique property of this set data structure which is not there in lists and tuples. That's why mainly this is the reason sets were introduced. Okay, so let's see how to create sets, right? So in order to create sets, we'll use curly brackets. If you see here, the set yes can be created by using these curly brackets, right? So this 1 2 3 are the items in the set yes, right? If you print yes, you will get this set, this line, you will get this line, right? Now if you print the type of yes, you will get it as set, type as set. So if we, let's say we have this set yes, right? In this set yes, if you see here, this item 1 is appearing twice, here and here. So it will be considered only once. While storing in memory, one will be stored only once, right? Now if you print yes, you will get 1 2 3 4. Though you entered 1 twice while creating set yes, it will be considered only once. Now we can make the set, we can you see we can make a set from lists also, right? So let's say I have this list 1 2 3 4 1 2 3 1. I can pass this list to a function or method called as set, and this method will create a set out of this list, right? That means yes is now a set containing these items. So if you print yes, you will get 1 2 3. So let's see how to initialize set. In order to initialize set, you have this, you can use this method called as set, right? I can so this will initialize this yes to empty set, right? So if you print the type of yes, it is set. Okay, so how to add an element in a set, right? So now we said that set is immutable data structure. So what do we mean by that? If s is equal to 1 comma 3, if you try to change or access the elements of a set by using the index, you will get an error, right? We know that if S is a list like this 1 3, right? So this list has indices, like this index is 0, this location is 0 index, this location is index 1, so on and so forth. So I can access the elements of this list by using the index. For example, s of 0 will give me access to this element, so I can put there, I can assign 10 there, let's say, right? So this is perfectly fine, absolutely fine, right? right? So this will replace 10. But if you try to do the same thing in case of sets, you will get an error, because sets do not have indices. Sets do not have indices. Indices are not there in sets. So that's why if you try to say s of 1, if you simply try to print s of 1, you will get an error, because sets do not support indices. So set object does not support indices. So then how do we add elements to a set? By using a function called as add, right? So we'll call a method add on set object, and to that method we will pass the item which we want to add it to the set. So I want to add 2 to the set, so I'll pass 2, and if you print s now, you will get 1, 2, 3. Already s was 1, 3, right? S was 1, 3. If you call add on this set s by saying s dot add and pass 2 to it, so 2 will be added to this set, so you will get s is equal to 1, 2 and 3, right? So you will get this output. Now if you want to add multiple values to a set, you can call this update function, right? And to that update function you can pass multiple values in the form of lists, right? So 5, 6, 1 is a list which we are passing to this update. So now s is 1, 2, 3, so we are calling this update on s, right? And to that update we are passing this 5, 6, 1. Now while adding this 5, 6, 1, 1 is already there in the set, right? So this 1 will not be added again, right? Only 5 and 6. So yes will ultimately become 1, 2, 3, 5 and 6. So now how to remove, again we can pass the list and sets to update function. That means if you see here, this is an update function which we are calling on s again. Now to this update we are passing a list, and also we can pass a set. We can pass both the things, right? So this 8, 9 will add 8, 9 to this set, and this function will add only 10, because 2 is already there in the set and 3 is also there in the set. That's why only 10 will be added, and you will get the output like this. Now how to remove an item from a set? So let's see that. So a particular item can be removed from the set using methods discard and remove. There are two methods which we can use to remove an item from a set: discard and remove, right? Let's say we have this set. If we print this set, we'll get this output, right? Now if I use discard, to this discard function I need to pass the item which I want to remove. So this discard will be called on the set object. This s is the set object. On this s we are calling discard, s dot discard 4. So this 4 will be removed, right? And if you print s now, you will have 1, 2, 3 and 5. Right? Also we can call the remove function. So let's see how to use remove function, right? And what is the difference between discard and remove? So s dot remove, now this is yes, this is yes. If I say s dot remove 2, again to remove we will pass the item which you want to remove. S dot remove 2, this will remove 2 from this set, so we'll get the output only 1, 3, 5. If you print yes, you will get 1, 3, 5. Okay. Now but the problem is, you see, now this is our set. This is our set 1, 3 and 5. Now if you try to remove an item which is not there in this set yes, you will get an error. So for example, on yes object you are calling this method remove, and to that method you are passing a number 7 which is not there in this set. So this will produce an error. This will produce an error. This error you will get, right? But on the contrary, if you call discard with the same item which is not there in the list, it will not give an error, right? Discard an element not present in set yes, that will not give you an error, though this will not remove because item is not there, right? But this will not give you syntax error. Okay, now there is one more method called as pop. So let's see how to use pop. So here is the pop method. So this is a set yes. On this set yes, we are calling this pop method. So this pop method removes random element. This will remove random element, right? So from this yes, this time pop remove this 1. So you will get this output. Again if you call pop, pop will remove one random item. So So this 2 will be removed, so you will get 3, 4 and 5. Yeah. So there is a method called as clear. If you call that clear method on the set object, it will remove all the elements of the set. For example, if this is a set, if you call s dot clear, if you call s dot clear, this will remove all the items, right? This set will become empty like this. If you print s now, you will get empty set. Now let us see Python operations, Python set operations. You have two sets, set 1 and set 2. Now there is an operation which you perform on sets in mathematics also. That operation is called as union, right? When you take union of these two sets, right, so that time we consider the duplicate items only once. That means the items which appear in both sets will be considered only once. For example, we have 3, 4 here and 3, 4 here as well. So while taking union, we will consider this duplicate items. Duplicate means the items which are getting repeated here and here. Those will be considered only once. So union of set 1 and 2, right, will be 1, 2, 3, 3, 4, 5 and 6, 7, right? That means this will not be considered twice, right? So union of these two sets can be taken by using this operator. This is union operator, right? Set 1 union set 2, right? This is a vertical line on your keyboard, right, with which comes with a backslash, right? On a key, right, there is a key where you have this vertical line and this backslash. So this vertical line we are using as the set union operator. So if you take the union, you will get this. You see, 3, 4, 5 was appearing in both the sets, but we considered it only once. Also, for taking union, we can use a method, and that method can be called on one of the sets, passing other set as a parameter or argument. For example, we are calling this union method on set 1, and to this union method we are passing set 2 as the parameter. So union method is called on the set 1 object, passing set 2 as the parameter. So this takes union of these two sets. Union method takes union of these two sets. We get the same result. Now intersection operator again. So intersection operator, now let us see what is intersection operator. In intersection operator, the result of intersection operator is the common elements in both the sets. So you see 3, 4, 5 was appearing in both the sets, set 1 and set 2. So that's why 3, 4, 5 is the result of intersection operator. So the intersection is denoted by AND operator, right? So AND denotes intersection. Set 1 and set 2 means set 1 intersection set 2. The result is the common elements in set 1 and set 2. For example, if I show you by Venn diagram here, so these are the common elements in set 1 and set 2. Only those will appear in the intersection. Again, the intersection can be taken by using the intersection method. You call intersection method on one of the set, passing other set as the parameter. We call intersection method on set 1 object, passing set 2 as the parameter. So the result is same. So set 1 minus set 2. Now here, if we have the set 1 as 1, 2, 3, 4, 5 and 6, and set 2 as, or let me take 3, 4, 5. It was 1, 2, 3, 4, 5. Then set 2 as 3, 4, 5, 6 and 7. Let's say that is set 2. Now set 1 minus set 2 means the items which are there in set 1 but not in set 2. What are the items which are there in set 1? Only 1, 2, 3, right? 4, 5 is, 1, 2, only 1, 2, 4, 5, 3, 4, 5 is here also, but it is here also, right? That means 3, 4, 5 will not come in set 1 minus set 2. So the items which are only in set 1 but not in set 2. Now 6, 7 is, there is no question of 6, 7 coming in difference, because 6, 7 is appearing in only S2, right? So the set 1 minus set 2 contains the items which are appearing only in set 1 but not in set 2. So that's why you will get the result 1 2. Again, set difference can be taken by calling a function difference, right, on this set 1, right. So set 1 dot difference set 2, right. So we are taking the difference of set 1 and set 2, right. Now there is something called a symmetric difference, right. So symmetric difference is nothing but set 1 minus S2. This will give us items which are there in set 1 but not in set 2. Now if I take S2 minus S1, this will give us items which are only in S2 but not in S1. If you take union of these two, this one and this one, you will get what is called as symmetric difference. So let's see what is symmetric difference. So this operator is used for symmetric difference, and now if you take the symmetric difference of set 1 and set 2, you will get 1 2 6 7. 1 2 is the result of set 1 minus set 2. 6 7 is the result of set 2 minus set 1. Yeah. Similarly, you can take symmetric difference by calling a method called a symmetric difference, right. We can call symmetric difference on one of these set passing other set as the parameter. Now there is something called a subset in Python. So what is a subset? So let's see. Now if I have two sets x and y, I can say that y is subset of x only if x contains all the elements which are present in y. I repeat, I can say that y is subset is denoted by this symbol. Y is subset of x only if, or if and only if, x contains all the items or elements which are present in y, right. Now for example, here y contains c and d. Does x contains all the items which are there in y? Yes, c and d is present in x as well, right. That means y is subset of x. Can I say that x is subset of y? No, I cannot say that. Why? Because y does not contain all the items or elements which are present in x. That's why y is not the, so that's why x is not the subset of y. So if we, how can we take subset in Python? By calling a function each subset, right. To this each subset, we are passing we are calling each subset on one of this set, passing other set as the parameters. Now so here I am calling this each subset on x, passing y as parameter. What do we mean by that? We are checking that x is subset of y. Is x subset of y, right? We are checking that is x subset of y. That means you are calling this function on an object which you want to check whether that object is subset of this object, right. We are checking, is this object subset of this set object, right. So if x is subset of y, the answer will be true. If x is not subset of y, the answer will be false. So this returns boolean answer, boolean value. Each subset returns true or false. In this case, x is not subset of y, that's why it will return false. Now in this case, y is subset of x, y is subset of x, that's why it will return true. Okay. Now let's see something called as frozen set. So what is a frozen set? Now frozen set is it's a set after all, but the idea is the frozen set is immutable. It is immutable. That means we cannot change the contents of the set. That's why it is called as frozen set. It is similar to tuples. Now what are tuples? Tuples are similar to lists, but tuples are immutable. Similarly here, frozen sets are sets, but they are immutable. That means you cannot change the contents of frozen set. So how do we create frozen set? There is a method in Python called as frozen set. We can use that method to create a frozen set. Now here you see we are calling this method frozen set, and to this method we are passing this list. So this method will create a set from this, but the idea is you cannot modify or change the contents of that set once created by using frozen set method. So we are assigning this frozen set to this variable, and this is a frozen set we are assigning to this variable. Okay, now if you try to add, you see set1 is a frozen set. If you try to call a method add, which we use for adding an element to a normal set, if you use the same method to add an item to this set1, you will get an error. This error, frozen set object has no attribute add. That means you cannot call add method on frozen set. Similarly, again it is as it is a set, so that's why if you try to access the elements of the set by using indexing, you will get an error, right, like this, right. We are what we are doing here, we are trying to access the contents of this set by using index, which is not supported. Okay, now frozen set supports all the operations like union, intersection, difference, right. Again, you can take set1 is a frozen set, set2 is a frozen set, you can take union of this in the same fashion which in which we took the union of normal sets. Again, intersection is also supported. Either you use this symbol or you call intersection method on one of the set, passing other set as the parameter, right. So if you do this, you will get same result, you will get 3 4. If you do this, you will get the same result. Again, you can take symmetric difference in the similar fashion.